All right, hey you guys, this is continuing to talk about 1.3. Checkpoint specifically is 1.19. We are in the section discussing the fundamental theorem of calculus part 2, so check it out. But I'm going to put it into practice. Here we're going to use that fundamental theorem of calculus part 2, which really is just showing us a way to evaluate integrals by hand, to evaluate the integral of x to the negative 4 from 1 to 2. So here's the setup. First of all, in order to actually evaluate this, it's like I'm ignoring the 1 and the 2 limits of integration, and I'm just focusing on x to the negative 4. If you remember the power rule would say that whatever our exponent is, in order to find its antiderivative, we're going to add 1 to that value, and then we're going to make that become the denominator of this coefficient of x to the m plus 1. And that really does work in reverse to check if that derivative works. You would multiply this times this, they would end up canceling. That's where you get the 1 in front of the original function. And then you would subtract 1 from the exponent, so m plus 1 minus 1, those cancel. We can do that with negative exponents and fractions. As long as we have an x that is the base of our exponent, whatever this constant is up here, we can follow the power rule for integration. It's a shortcut, really, but we'll use it. Negative 1 plus 4 is actually going closer to 0. Negative 1 plus, I'm sorry, I said that backwards. Negative 4 plus 1. There we go. Negative 4 plus 1 is getting closer to 0. So negative 4 plus 1 being negative 3. That is our denominator of our new function. And then x to the negative 3, right? So these should match. That way when you multiply them, they would cancel each other out. And that would be the checking derivatives. We're going to evaluate from 1 to 2. You might have seen me do different notation, slightly different notation in a previous one. Yes, these are actually equal expressions. What you might have seen me write is something like this: negative 1/3 of x to the negative 3 from 1 to 2. What I'm really trying to do is isolate the only thing that has to be evaluated. So in this case, the only thing that has to be evaluated is 2x to the negative 3 and 1. That's the 1 to the negative 3. So we're going to rewrite this as negative 1/3 times 2 to the negative 3rd minus 1 to the negative 3rd. Thank you, Fundamental Theorem of Calculus, Part 2. All of these are equal. Now just do your evaluations. 1 to the negative, this is 1. 2 to the negative 3rd is 1 over 8. So we're left with negative 1/3 times 1 over 8 minus 1. And continuing further to evaluate 1 over 8 minus 1, that would be negative 7/8. So negative 1/3 times negative 7/8. Multiply straight across. The negatives cancel. You're left with 7/24. If along the way you feel like you've made a mistake, you can probably see that negatives are going to be a problem. Factors and constant multiples are going to be a problem. Let's just jump into Desmos and let's just do the direct definite integral. Let's evaluate the definite integral of, move there please, x to the negative 4 from 1 to 2. You can find the integral function in the miscellaneous button, but I'm also going to just type from my laptop int, and that's going to pop up the integral sign too. 1 and have to move up 2, and then x to the negative 4. Don't forget dx or it won't evaluate it. Is that really 7 to the divided by 24? Well, let's click the fraction button in Desmos and find out. Booyah. Thanks for watching this video.